So let us start this. And earlier we have a discussion about this type of friction and all, and we discussed about this type of different types of friction and what are their connections, how they are connected. And I told you one method how to remember the idea of friction, that you have to focus on this particular part where this slide always find f limiting. Second thing is you have to find f required or f present. And third thing is, if f required is f limiting, then the body is not going to move, but when f required is more than f limiting, the body is going to move. Is that clear or not? And we are going to take this idea forward. Okay, but before that, one more concept which we have to do, and that is called as angle of repose. Okay, now look over here. इसमें क्या करना है, like the idea is that let's suppose you took an inclined plane, and this inclined plane is again rough inclined plane, got it or not, and you placed any body over here, any block over here, got it or not. Now when you are going to place any block, got it, like let's suppose I place this block over here. So let's suppose this body has mass m, and this inclination is how much, theta. This surface is rough with coefficient of friction is equal to mu. So this mass will slide down with the how much force? Basically, if we try to resolve the forces on this mass, so its weight is vertically downwards, correct? And this is the direction of normal, correct? 1 minute. This is the direction of normal. Now this mg can be resolved in two directions. I can consider along the direction of normal itself, okay, which is like this way, and we know that this angle is also how much, theta, and this is going to be the component mg cos theta, and along this side it is going to be how much, mg sin theta. Now idea is that, see, if the block has always a tendency to fall down, correct? This block has always a tendency to fall where? Downwards with acceleration. Now if means to make the acceleration of the block let's suppose I want to make the acceleration of the block to be how much, 0. So minimum required friction of mine is how much, mg sin theta or not? Say me something, yes or no? And you know that along this direction the friction will be present, correct? Now this friction will have three different values: static, kinetic and limiting. Idea is that the maximum value of inclination, see, this inclination will always make the body to move down. Okay, now I want that for what value of angle theta, maximum value of angle theta, the body will not fall. So during that time, again, which force will act? Maximum frictional force will act. Say me something, yes or no? And this maximum frictional force must be exactly equal to F required, then only the bodies are not going to fall. Is that clear or not? Now value of F max is how much? Mu into n, and that is equal to mg sin theta. Mu we know, and n is mg cos theta, which is equal to mg sin theta. So this means that theta must be equal to tan inverse mu. Means if you can supply to an inclined angle, theta is equal to tan inverse u. What you are going to see that whatever the block, whatever its mass is, okay, I don't care, whatever its mass is going out to be, this block will never ever slide. Is that clear or not? And this is why this angle is called as, its name is given, angle of repose. What it is called as, angle of repose. Is that clear or not? समझ में आया कि नहीं आया? कि भाई सिंपल सी बात है कि जितना भी मैक्सिमम वैल्यू थीटा का पकड़ ले, उस मैक्सिमम वैल्यू पे गिरना नहीं चाहिए. तो उस मैक्सिमम वैल्यू पे लगेगा क्या? मैक्सिमम फ्रिक्शन लगेगा. उससे ज्यादा फ्रिक्शन तो पॉसिबल नहीं है ना. तो उस थीटा के लिए जहां पे मैक्सिमम फ्रिक्शन लगे वहां पे अगर वो एफ रिक्वायर्ड के बराबर हो जाए तो उसके ऊपर अगर जाएगा तो बॉडी स्लाइड कर जाएगा, उसके नीचे रहेगा तो बॉडी कभी भी स्लाइड नहीं करेगा। तो थीटा की वैल्यू हरदम क्या रहनी चाहिए, tan इनवर्स म्यू। इसका मतलब if theta is, if the inclination is less than this theta, the body will not slide. If the angle is more than this theta, then the body is definitely going to slide. Are you able to get me or not? And this is the meaning of angle of repose. Now question arises, so let's check that whether this angle of repose condition is available at any random scenario also or what. So let us just check. Let's suppose if I have an inclined plane, okay, of inclination 37 degree, and I placed a block of mass m whose mass is 5 kg, and the surface is rough. No, I don't know. Coefficient of friction mu is equal to 0.5. Question is very simple. Find the acceleration and friction present between the blocks. Find the acceleration and friction present between the blocks. What can be that? See, अच्छा इसमें स्टेप क्या लगाएंगे शुरू जी, सबसे पहले क्या निकालेंगे, एफ, एफ मैक्स पहले निकालेंगे, क्या निकालेंगे, हाँ, तो पहले तो रिजॉल्व करो इसको, फर्स्ट रिजॉल्व दिस, फर्स्ट ड्रॉ द एफबीडी, ओके, दिस इज mg, this is its normal, and this will be the direction of friction. Clear? Three forces are there, mg, normal, and my friction. Now along the normal, this mg has two components, okay, wait or not, one along the normal, one along this side. Now this is going to be again same 37 degree, this will be exactly mg cos 37, this will be mg sin 37. Check. Now f max is what is the formula of f max, mu into n. Mu value is how much, 0.5, and normal is going to be how much, look over here, it is mg cos 37, 0.5, yes. Now cos 37 is, mass is 4 by 5, so 5 cancel, this is 10, so this is how much Newton, 20 Newton. Now I want to find f required. See, what is my f required going out to, means how much is the friction required to stop it, that is exactly equal to mg sin 37, correct? If I can supply mg sin 37, body will never ever move. So m is how much, mass is 5, gravity is how much, 10, and sin 37 is 3 by 5. How much is this Newton? So we can see that f required is more than my f limiting or not, correct? So this means that the blocks are going to slide. Are you able to get me or not? And if blocks are going to slide, they will have some acceleration or not in this direction. Who is joining? Okay. So these blocks are, 1 minute, let me check. So these blocks are going to slide, and if I want to find their acceleration, So I'll tell you one. Yesterday I described you one acceleration method. I told you acceleration is pulling force minus opposing force divided by total mass moving. So here pulling force is how much? Mg sine 37. And as you can see that F required is more than F limiting, means body is sliding. This friction will change to which friction? Kinetic friction. And divided by mass m. Is that clear or not? So this is how much? 5g sine 37 minus mu mg cos 37 divided by mass how much? 5 kg. Is that clear or not clear? That's your acceleration. And kinetic friction is, since mu I have given same, so kinetic friction is exactly equal to F max. Are you able to get me or not? Is that clear or not?
Yes, sir.
So this is the idea. So every time your work is to do only one thing, find the F limiting. Is that clear or not?
So,
Okay, so let us just do one series of question, got it or not today. Look over here. Let's suppose there is an inclined plane. Got it. And so we are going to today clear our all ideas of incline anyhow, got it or not? Full idea. And let's suppose there is a block whose mass, how much mass I should keep? Let's suppose 2 kg mass is there, and this inclination is 37 degree. Okay, the value of mu is let's assume that 0.2. Value of mu is how much? 0.2. And what I'm doing is I'm applying one extra force, and let's suppose this value of force is capital F, word or not? So case 1, what means you have to tell me acceleration and all the things when I'll take different values of forces, word or not? Okay, is that clear? Hello, Sruji, can you hear me? Is this clear or not?
yes.
Okay, so let's take an example. Let's suppose if this force value is exactly 4 Newton, then you have to tell me what will be its acceleration and what will be its friction present. Okay,
Wait, 2G sine 37 for the minus 4 and 20, right?
सोचो.
ये तो डायरेक्शन में जाने वाला. तो अब प्राप्त करेंगे तो एक्चुअली ये बता.
सोचो क्या होगा. टेल मी व्हाट विल हैपन, जस्ट सोच, देख पहले तो इसको एफबीडी ड्रॉ कर यार, कुछ भी हो क्वेश्चन का एफबीडी ड्रॉ किया जाता है एनालिसिस में तो दिस इज हाउ मच 2g, इधर कितना आएगा 2g cos 37, सॉरी 2g sin 37, एंड इधर 2g cos 37, करेक्ट, and this is 37 degree. This is my normal. Okay, ये क्या हो गया तेरा नॉर्मल. नाउ मैंने फोर्स ऊपर लगाया, तो पहले तो हमें एफ रिक्वायर्ड फर्स्ट, नॉट एफ रिक्वायर्ड, फर्स्ट टास्क इज फाइंडिंग एफ लिमिटिंग. स्टेप 1, व्हाट इज द वैल्यू ऑफ एफ लिमिटिंग? ऑलवेज म्यू एम जी कॉस थीटा. सेमी समथिंग कैसे नो, म्यू की वैल्यू कितनी दी गई 0.2, मास कितना दिया गया है, मास कितना दिया गया है तेरा 2 kg, ग्रेविटी है 10 एंड कॉस 37, तो कितना हुआ ये 4 इंटू कॉस 37 क्या हो गया 4/5, कितना हुआ ये तेरा 16/5. ठीक है, एक काम कर, इसको एक काम चेंज करते हैं थोड़ा सा मास, ताकि कैलकुलेशन इजी रहे. मास को लेट सपोज लेट्स टेक इट एज, और लेट्स टेक दिस मास एज 2 kg itself, and let's change mu value as 0.5 such that our calculation should go on easy task. Okay, so mu value is how much? Let's put it, this is 0.5, so that the fraction will not come, I can have an easier calculation. Okay, so this is how much 5 into 2 into 4/5, how much is this Newton? 8 Newton. Now, F limiting is 8 Newton, while F required to stop this, let's suppose if I apply a 4 Newton force, and if I take 2g sin 37, how much is this? 2 into 10 into sin 37, 3/5. So this is how much? 3 to the 6 to the 12 Newton. So look over here, this is 12 and this is 4. So if I look into that, body has still a tendency to go downwards or not? So in this case, F required is how much? Exactly 8 Newton, and that too in downward direction or not? So, sorry, upward direction, not down. If required in which direction? Upward direction. Are you able to get me or not? Is that clear or not? Basically, this is 4 and this is 12. So net effect is how much? 8 Newton in downward direction. So I need F required in which direction? 8 Newton in which direction? Upward direction. Is that clear or not? Now, if I get to know okay, if I get to know this 12 Newton and all, now look over here. F limiting is also 8 Newton. So definitely my F required over here is exactly equal to F limiting or not. So this means again what? Acceleration will become how much? 0. हाँ बताओ. हाँ हाँ, F required क्या क्या, जोर से बोलो थोड़ा. हाँ 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 हाँ. हाँ तो मैं तो वही तुम्हें बोल रहा, नहीं नहीं सुनो, समझो समझो, ये एफ रिक्वायर्ड तुम्हारा फ्रिक्शन का रिक्वायरमेंट है. मैं ये स्मॉल एफ रिक्वायर्ड का मतलब है फ्रिक्शन रिक्वायर्ड, कि इसको स्टॉप करने में कितना फोर्स लगेगा. 12 न्यूटन से नीचे खींचे, हाँ 12 न्यूटन से नीचे खींचे और 4 न्यूटन से ऊपर ढकेले, तो इफेक्टिव कितना है 8 न्यूटन नीचे है, तो हमें चाहिए कितना 8 ही न्यूटन चाहिए ना ऊपर की ओर, ताकि ये स्टॉप कर सके. तो दिस एफ रिक्वायर्ड, हाँ क्लियर हुआ. हाँ, so this F required is exactly equal to F limiting or not. तो इसका मतलब again what will happen? Acceleration will become how much? 0. Means this body is not going to fall. Is that clear or not? And if acceleration is 0, what will happen? In upward direction, friction present is F limiting. I can write the conclusion as friction present is if limiting in upward direction and its amount is 8 Newton. Is that clear or not? And its amount is how much? 8 Newton. Are you able to get me? Clear or not clear?
Clear.
Now, same example, same thing. You means this time we have to do the range of forces. Okay, means we are taking just examples, different kinds of example. Okay, second scenario. If I take, so I took. Actually, I should have taken this as second scenario. First scenario. Let's suppose if I apply force of 2 Newton only, what will happen? Now, if F is equal to 2 Newton, what will happen? So, F limiting is acceleration. Let us check. F limiting is still how much? F limiting, it will be still 8 Newton only. Yes or no? हाँ, but F required कितना है? कितना requirement है ताकि ये रुक सके? This is 12 Newton and this is how much I am supplying 2 Newton. So this is 10 Newton in upward direction or not? But I can maximally supply how much frictional force? 8 Newton. So again, what I found out that F required is basically more than F limiting. What will happen to the block? This implies that block accelerates downwards. Is that clear or not? Say me something, yes or no? And block will accelerate in downward direction, and that acceleration is going to be how much? A will be pulling force. See, again, pulling force is how much? 2g sine 37 minus opposing force is capital F and minus my kinetic friction or not divided by mass which is moving. Say me something, yes or no? Is this clear for everyone or? हाँ हरिओम बताओ. हाँ बोलो. हाँ हाँ हाँ. अगर मान लो हम ऐसा फोर्स लगाएं कि दोनों का एफ नेट जीरो, हम आएंगे, हम सारे केसेस पकड़ने वाले हैं. ऐसा नहीं कि एक दो केस पकड़ने वाले, इस पे हम टोटल 6 केसेस पकड़ने वाले हैं. आने वाला हूँ, थोड़ा सा और टाइम दो बस. ठीक है. हाँ थोड़ा सा देखो अभी. हाँ हाँ मतलब देखो समझो एक बात. अगर बॉडी का एक्सेलरेशन मतलब तुम्हारे फ्रिक्शन में सिर्फ तुम्हें दो ही चीजें निकालनी है, और वो दो चीज का नाम है एफ लिमिटिंग और एफ रिक्वायर्ड. अगर तुमने एफ लिमिटिंग और एफ रिक्वायर्ड निकाल दिया तो तुम्हारा आंसर ऑटोमेटिक आ जाएगा, तुम्हें कुछ सोचना ही नहीं उसके बाद. समझ में आया? अब एफ रिक्वायर्ड क्या है? एफ रिक्वायर्ड इज दैट फोर्स विच आई एम यूजिंग इट टू सी that under what value of frictional force the body will be at rest. Means F requirement is that force where we are thinking that the body will be in rest. Is that clear or not? Okay, so F required is not the force for seeing that whether it will be in motion or not. F required is that force for which the body is in rest. Is that clear or not? For which the body is in rest due to friction, not also due to other forces. Due to what? Friction. Are you able to get me? समझ में आ गया? तो देखो अब मैंने यहाँ पे क्या देखा कि टू स्टॉप माई बॉडी आई नीड 10 न्यूटन, बट from the surface I can get maximally how much Newton? 8 Newton. So is the body is going to accelerate or not? Definitely the body is going to accelerate. But where it will accelerate? Here, this time in upward direction, my frictional force is required 8 Newton, 10 Newton. But I can supply maximally 8 Newton. So the body is going to accelerate downwards or not? Because this 12 Newton is means very pulling it downwards. Are you able to get me or not? समझ में आई बात? क्या ये मेरी बात पूरी तरह से क्लियर हुई तुम लोगों को? अरे कुछ तो बोल दो, हाँ या ना? ठीक है, तो अब ध्यान से देखो। अच्छा, थोड़ा बहुत माइक ऑफ करके रखो, ठीक है। सो दिस विल बी हाउ मच? 20 sin 37 is 3 by 5. Force applied at that time is 2 Newton, and kinetic friction will change to limiting friction if mu s is equal to mu k. So this is how much? 8 Newton in downward, and how much mass is that moving? That mass is 2 kg. So I can find the acceleration. I'll get the value of acceleration from here. 5 4s are 20, 4 3s are 12, minus 10, which is 2 by 2, and that is 1 meter per second square. In which direction? Downward direction. Is that clear? Are you able to get me or not? So this is the meaning of friction. Is that clear? Now, what if in the same question everything is same? Okay, I'm doing it something. Let me just have a snap note of this. Control C, next Control V. Yeah. Now look. Again same thing. This time my force, third scenario, this force is exactly equal to 8 Newton. Tell me what will happen. अपवर्ड जाएगा? सोचो. Now this force is 8 Newton, this is 12 Newton. Again, where is my net pulling force? 4 Newton downwards. So again, if I write F required is how much? 4 Newton in upward direction, correct? Again, F limiting is how much? This time F limiting is still same, which we have used, 8 Newtons. Look over here, F required is, see, this force I'm taking it to be how much? 8, and this force is how much? 12. So you can see that is still there is a downward force extra 4 Newton or not. So the body can definitely go down with 4 Newton in which direction? Downward direction. So I need how much force to stop this motion? I need exactly how much force in upward direction? 4 Newton to stop this motion. Are you able to get me? And this is my F required, 4 Newton in upward direction. But F limiting is how much? 8 Newton. So again, what I saw, that friction required to stop this motion is basically less than F limiting. So this means that the body remains in rest. The body remains in what? Rest. Are you able to get me or not? And as the body is in rest, which frictional force will occur? A static frictional force will occur, and that static frictional force, because here F required is very less than F limiting, not equal to also, F static will occur, which will be exactly equal to my required frictional force, and that is how much Newton? 4 Newton. Till this it is clear or not clear? I want yes or no.
Yes, yes.
Can you understand the method fully or not? See, I took a, means I'm telling you one and only one concept. Look into F limiting and look into F required. If it means you have to remember this particular slide, always find F limiting, and second thing is find F required or required frictional force to stop the body. If you found that required frictional force is less than F limiting, the body is never ever going to move, and at that time which frictional force will occur? Static frictional force will occur, which will be exactly equal to F required. And here, if F required is more than F limiting, which frictional force will occur? Kinetic frictional force will be present, which will try to stop the body, but it cannot stop. The body will still have acceleration, and that's what we saw over here. I took three different examples for Newton. Here, F required was exactly equal to F limiting, so body is at rest, but which friction is going to be present? Limiting friction present. Here, what I saw, F limiting is 8 Newton, and F required is how much Newton? 10 Newton. So basically, the body is going to accelerate, and what will happen, the friction will change into kinetic friction, and I can find the acceleration. Is that clear or not? And then I saw the third case where required friction is again less than limiting friction. The body still remains at rest, and if static is equal to F required, which is equal to how much Newton? 4 Newton. This is what is happening when I say 248 Newton. Question arises, what happens to the same scenario if you take the force to be F is equal to how much? 284 done now. Should we say 10, or let's take 12 Newton? Tell me what will happen. जल्दी से बताओ, जल्दी, बिना सोचे बताओ, जल्दी से. रिमेन एट रेस्ट, एक ऑप्शन आया. दूसरा कोई? सुरुचि, हरिओम, बहुत सारे आज नए नए लोग. रेस्ट पे रहेगा क्या? और फ्रिक्शनल फोर्स की वैल्यू क्या होगी? फ्रिक्शनल फोर्स की वैल्यू, हाँ हाँ, कितना रहेगा? हरिओम कितना? ललिता, आज तो बहुत सारे लोग आ गए हैं. और कैसा चल रहा है केसीसी? क्या हमारी याद आती है बच्चों? वासु, अरे वासु, और बताओ. उमाकांत सर का क्या हाल है? कैसा स्पीच दे रहे हैं आजकल? और ये बताओ, वो प्लांट की स्टडीज कैसी चल रही है? जंगलों में खेती बाड़ी कर रहे हो तुम लोग? अच्छा अच्छा, चलो पहले क्लास ले लेते, उसके बाद बात किया जाएगा. एफ इज इक्वल टू 12 न्यूटन. अब मान लो तुमने 12 न्यूटन लगा दिया, नीचे की फोर्स है 12 न्यूटन, मींस यू आर पुलिंग द बॉडी बाय दिस mg sin theta is pulling the body by 12 न्यूटन. You applied in upward direction 12 न्यूटन. So net force is how much? Already 0. So F required, my required friction is itself how much? 0. And if F required is 0, also acceleration is how much? 0. So these all three things are present at the same time. Are you able to get me or not? When I apply a force of how much Newton? 12 Newton. What? हाँ, यहाँ पे जरूरत ही नहीं है ना, क्योंकि मेरा ऊपर का फोर्स और नीचे का फोर्स दोनों ऑलरेडी बराबर है, तो फ्रिक्शन का काम ही क्या है? कुछ नहीं है वहां. फ्रिक्शन की वैल्यू ऑलरेडी 0. ठीक है. नाउ नेक्स्ट, इसी में बढ़ा दो. लेट्स अगेन इंक्रीज द फोर्स, मेक इट 16 न्यूटन. तुम्हें आज फ्रिक्शन में पीएचडी करवा दूंगा इंक्लाइन ब्लॉक का. ऐसे काइनेटिक फ्रिक्शन बनने लगा कि नहीं बनने लगा? फ्रिक्शन ऊपर है या नीचे? ऊपर ज्यादा है. अबे तो चलेगा कैसे? एफ रिक्वायर्ड तो फिर भी 4 ही न्यूटन है. बॉडी विल रिमेन एट, see, this time F is equal to 16 Newton, and yes, F is 16 Newton. My F required is how much Newton? This is 12. I applied 16 Newton in upward direction. So I require only 4 Newton in downward direction, such as to stop my body or not. Say me something, yes or no? Yes, correct. And I can still create limiting friction in downward direction, which is my how much Newton? 8 Newton. Again, my F required is what? less than F limiting, what will happen? Acceleration 0. Which friction will come? Static. And which in which direction? This time it is in downward direction, not in upward direction, and that will be how much Newton? 4 Newton. Don't do any question before finding this inequality. Don't reply. Okay, word or not? श्रुचि क्लियर हुआ
हो गया.
पूरी तरह से? So see, friction can be in any direction, Balak. It does not mean that friction means work of friction is only to be in upward direction. You have to see the direction of motion. Friction can take any value. F limiting can be present in upward direction also, downward direction also. And based on that, I can have the different values. Are you able to get me or not? Got it? Again, cut paste, change the force. 20 newtons. Today we will do PhD. Tell me fast, without even thinking. Again, F limiting, how much? Same, 8 Newton. Abhi, in upward direction, how much is that? 20. And downward direction, how much is that? 12. So F required in downward direction is how much Newton? 8 Newton in downwards. Can this F limiting can provide it or not? Why? Because F required is exactly equal to how much? F limiting. And if F required is equal to F limiting, again acceleration is how much? 0. Force, frictional force will be basically F limiting, and that is equal to how much Newton? 8 Newton. Are you able to get me or not? Next, control V. Let's again check. 24 Newton. Tell me the answer.
Body will move upward.
Find the acceleration and friction both.
Friction will be 8 newtons. Acceleration will be 4 meters per second.
Let us check it. Let others do.
Acceleration
Acceleration will be
2 meter per second square.
friction
8 meter.
8 Newton. Others, Hariom, बना?
Friction 8 newton होगा और acceleration का निकाल लो.
Acceleration निकाल लो जल्दी से. Again here F limiting 8 Newton, F required, and this time F required, this is 24 and downward is 12, so 12 Newton in downward direction. But what I found out over here, that F required is more than F limiting. This means that body slides upwards, and if body is going to slide upward, it will have some acceleration, Balaks, and that acceleration is again same thing, pulling force, which is capital F. Capital F is in the direction of acceleration, okay, and the two forces which are in opposite direction is 2g sine 37 minus friction will change to kinetic friction divided by mass which is moving. Is that clear or not? So A will be 24 minus 12, and kinetic friction is equal to limiting if mu s is equal to mu k, and that is minus of 8 divided by mass 2 kg. How much is that? 4 by 2, which is 2 meter per second square, and that in which direction? Upward direction. This is the range of inclined plane questions which can be asked to you. So did we did PhD in this or not? Any kind of doubt, tell me. Clear? अरे someone say me, Balaks, clear or not clear?
Clear.
Clear, clear.
Everything is clear or not? If you are studying from Dr. Funsuk Wangdo, then you can understand the level of physics where we'll go. अरे सागर, सागर का भी मैसेज आ रहा है। कैसे हो सागर? लाइक सब्सक्राइब एंड शेयर मेरे दोस्तों, मेरे बच्चों। ठीक है, आग लगा दो केसीसी में। ठीक है यार, पहले वाला फील आ रहा है शुरू से। आग लगा दो। कैन यू मूव अहेड? तो हरिओम, अभी नए नए बच्चे आए, ज्वाइन हुए हैं कि नहीं हुए हैं?
सर
अच्छा, सुना कि पूर्णा मैम छोड़ के चली गई क्या भाई? हैं? उन पता नहीं, मतलब उनका स्टेटस आज देखा था, लिखा हुआ था न्यू बिगिनिंग। हमने बोला ले कट गया पत्ता इनका भी। अच्छा, ठीक है, कोई बात नहीं। जब तक तुम्हारी जिंदगी में मातम साया है, मनाते रहो मातम तुम लोग। ठीक है, लगाओ एक और क्वेश्चन, तब तक मातम साया की याद में। ठीक है, हम तो मतलब कतई प्यार करते हैं वहां के लोगों से, हमें क्या दिक्कत। ओके, लुक ओवर हियर। थोड़ा सा कॉम्प्लिकेटेड क्वेश्चन डालता, थोड़ा सा इजी क्वेश्चन डालता, उसके बाद फिर से कॉम्प्लिकेट करूंगा। थोड़ा सा मजे ले लो तुम लोग फिजिक्स के। लेट्स टेक लिटिल बिट डीप ब्रेथ of understanding of physics such that you can survive a little bit of my questions. Now look over here. Again, I took a two sample problem. Again, same scenario. Masses are given as this one is 3 kg and this one is given 2 kg. Okay. The surface is again rough and mu value is given as 0.5 once again. And same thing, find the acceleration and tension in the thread and friction present. Find the acceleration, comma, tension in thread and acceleration present. And friction present, sorry. Tell me fast.
friction force will be 15 Newton, acceleration will be 1 meter per second square, and tension
सोच बक जरा।
tension equal to 18 Newton.
अच्छा, अदर्स जल्दी बता दो यार। टेल मी फास्ट द आंसर।
That tension is 17.6 Newton,
हाँ हाँ।
acceleration I is 8 meter per second square around.
हम्म। ओके, अलग आंसर आ गया ये तो मेरे पास। एनीवन एल्स? रुचि? भाई मैं, पता है, इस चैनल का नाम रख देता हूँ बिचिंग ऑफ केसीसी, है ना? मजा आएगा यार। और ललिता कैसी हो? यहाँ पे कितने सारे लोग आए हैं। वैष्णवी, वैष्णवी याद तो आ रही है। ये नीट 2026 कौन है भाई? अच्छा, जो बीच बीच में बोल रहा है, लंबा सा घोड़ा, वही है क्या? कौन? हाँ हाँ, अरे तो वही तो बोला, लंबा सा घोड़ा। टेल मी द आंसर फास्ट गाइस, सी।
Acceleration 0.9 square,
हम्म।
answer 17.6,
अच्छा,
direction 14.7,
लेट्स लेट्स चेक। सुरुचि, तेरा आंसर नहीं आया। वेट कितनी हो गई? 2g, and this is what, tension T, correct? This is also tension T. Like in any kind of this kind of thread and block problem, if you see that below mass is lesser than the up mass, and this surface is not smooth, again go back to the same idea. Find F limiting first of all. You don't know what can happen. F limiting is simply mu mg over here. Mu is 0.5, mass is 3, and gravity is how much? 10. This is how much Newton? 15 Newton basically. But if I look into F required to stop this, see, if F required means the for condition for which acceleration is 0. If acceleration is 0, then this tension need to be 2g, and this tension is also need to be 2g. Means F required is how much? 20 Newton. I found out that F limiting is less than, sorry, less than F required. So this means that the body will accelerate. Of course, the bodies are going to do what? Acceleration. Now, I'll tell you again, use ATH, Anurag sir theorem. I have given a name now, and you should also say that again. Acceleration is pulling force out of all these bodies, which is who is pulling it? 2g is pulling it. So 2g minus these tensions will cancel, because net tension on the thread is going to be 0 all the time. Is that clear or not? Can you understand my point or not? Net tension is how much? 0. Why? Because this thread is not breaking. Are you able to get me or not? So look over here. What will happen? This is 2g, and this means, see, I'm telling for the value of acceleration, net tension is 0, not for the normal scenario. Okay, if you look at one point of the thread, definitely there is a tension. Is that clear or not? But if you look in the all the points of the thread, net tension is how much? 0. Is that clear or not? So therefore acceleration will be written as 2g, which is my pulling force. Net tension is opposed, but this time what will appear over here? A kinetic friction will appear. Right or not? Because the F required is more than F limiting. So this is minus of kinetic friction divided by total mass moving. How many masses are moving? This time 2 plus 3, 3. So this is 20 minus kinetic friction will be F limiting if mu is given same, and divide by 5. So A is equal to how much? 5 by 5, which is 1 meter per second square. Who got this answer?
I got it.
Okay. So acceleration is how much? 1 meter per second square. Now, अच्छा अच्छा 9.8 लेके बनाया था क्या? तो अब लगा दे टेंशन. हाउ टू फाइंड टेंशन? पुलिंग फोर्स 2g minus tension T is equal to twice into acceleration. So T is equal to 20 minus 2, which is how much Newton? 18 newtons. Is that clear or not clear?
Yes, sir.
Clear. हेडिंग लगा दे, maximum value of friction, or you can say minimum value.
हाँ, पढ़ा
क्या क्या?
मैंने पढ़ा के तो मैं
अबे पहले पढ़ा देता तो फिर मेरी भाव कैसे बढ़ती, कैसे मालूम चलता कि देयर वाज अनुराग सर, है ना। अब ऐसा बात नहीं यार, टाइम नहीं मिल रहा था यार, बहुत वर्क करना पड़ रहा है एलन में। तो मैं एकदम टाइम नहीं मिल रहा मेरे को। मैं तो मतलब ऐसे समझ लो ना कि मतलब सोच तू भाई, 2 महीने में शादी है यार, तुम लोग को पढ़ा रहा हूँ, बच्चों की तरह पाल रहा हूँ
तो इसलिए बस वगैरह तो हमारा छोड़ दिया था।
मैं। देख कोई नहीं, वहां पे जो पढ़ा, अभी कौन पढ़ा रहा है तुम लोग, मौर्य सर पढ़ा रहे हैं क्या?
कौन ऐसा पड़ा है?
हाँ तो
कोई
पढ़ो।
है भी,
हाँ हाँ।
कोई है भी।
हाँ, ठीक है।
फेवरेट सर है कौन?
हाँ, बच्चे ही नहीं, इस साल तो बच्चे बहुत कम आए हैं ना, कितने आए हैं?
150 बच्चे, 150 200।
ठीक है, कोई नहीं कोई नहीं। उनको यार, उमाकांत सर को अपने पापा को याद करना चाहिए यार, यहाँ पे बैठा हुआ हूँ, बुला लेते एक बार यार। बुलाते हैं नहीं, बुलाएंगे तब तो जाएंगे। यार ऐसे बोलना नहीं चाहिए, मालूम चला वीडियो रिकॉर्डिंग उठा के देख लिया मतलब वाह की आंख। ठीक है, नल्लू को बढ़िया। मिनिमम, अरे यार क्या लगा दिया, मिनिमम वैल्यू ऑफ फोर्स। अब सोच जरा, दिस इज अ वेरी गुड कॉन्सेप्ट, अगेन लेट्स गो बैक टू आवर concept understanding, jokes apart, come on, let's not beach too much of KCC, it's a bitch, I know that। भाई इतना ट्रॉमा दिया है ना यार, सालों ने पैसा नहीं दिया यार मेरा, पता है तो। now look over here, let's suppose there is a block of mass m, and this mass m is pulled by some force F at an angle theta, okay। तो अच्छा से ड्रॉ कर रहे हैं तो अच्छा ही लगा, at an angle how much बालक्स, theta, okay। now this surface is rough, once again the surface is rough, coefficient of friction is mu। Question arises that how much minimum value of this force, how much minimum value of this force I should apply such that the whole thing starts to accelerate or starts to move, at least it should move, okay। Question is how much, सुरुचि इधर ही है ना, how much F minimum must be applied such that the body accelerates, again you have to again look into the basic idea that how to apply the force, think about that, you can do it, try to do it। one of the classical questions of HC Verma, example number 11, okay। Tell me,
mu mg minus mu f sin theta by cos theta।
wrong।
फ्रिक्शन फोर्स प्लस f sin theta।
हाँ हाँ,
फ्रिक्शन फोर्स प्लस f sin theta स्क्वायर sin theta।
wrong। अबे यार, क्वेश्चन तो हमारे साथ तुम्हें मालूम ही है कौन घुमा करते थे, डॉक्टर लाहौटी। अरे तो कोई बात नहीं, हम भी एलन में हैं, कम थोड़ी ना है। क्या क्या क्या?
ऑनलाइन 40 मिनट चैप्टर खत्म करा देते
अच्छा अच्छा, वो क्रैश कोर्स में थे फिर।
हैं। हाँ,
अभी तो शायद मुझे लग रहा है पीडब्ल्यू से भी निकल गए हैं वो।
नहीं नहीं ऑनलाइन
अच्छा अच्छा, कोई नहीं, इधर देखो।
पावर बैटरी कोई
हाँ हाँ।
चैनल का चैनल
अरे तो अपना भी तो चैनल है अनुराग सर का। यार, ध्यान से देख लो। अब मान लो, अच्छा इस फोर्स को रिजॉल्व किया, लेट्स रिजॉल्व दिस फोर्स हैज टू कंपोनेंट ना, एफ cos थीटा, एफ sin थीटा, करेक्ट? दिस weight is how much? mg, and then the normal will be there in upward direction. This is my end, correct? If I want to write my normal, if you look into the value of normal, normal is this time not same. Normal is written as over here this time mg minus f sin theta, correct or not? So you want to apply a minimum force such that the body should move. Idea is that see, I kept the block, I applied some force, the body starts to move, little bit starts to move. I am looking at F minimum. The work of friction is what? What is the basic definition of friction? To maximally oppose the motion. Means this body should not slide. I am applying such a force such that this body should at least try to come into motion at that instant of time. Which friction will work? Maximum friction will work or not? Say me something, yes or no? Because see, means let's suppose idea is that let's suppose you are in your home, okay, and to go into any some kind of market, like you want to go to some Disneyland or not, and you need some money. You say that at least one particular ride if I want to take, I need at least 100 rupees. So, and what is happening in your home, that they are saying that I cannot give you that much money, I cannot give you too much of money, okay, but you are saying at least I should apply 100, at least I should get 100 rupees to get out of the home and go into that Disneyland. So what home people will say, okay, let's you take 100 rupees, that can only I can supply, more than that I cannot supply itself. Is that clear or not? So basically idea is that, simple idea is that here also same thing is happening. Body wants to move, but it is stopped by a value of maximum opposing force, which we call it as F max. So how much minimum it should apply? It should definitely apply at least F max to move into a constant velocity state or not. Say me something, yes or no, guys? Did you understood my meaning over here? Tell me. Reply me, yes or no. Clear? So So this means that F max must be exactly equal to how much? My mu n, and anyhow that must be equal to, means this frictional force must be exactly equal to my minimum applied force, which is my F cos theta in horizontal direction, such that the body should start moving, such that the body starts to have tendency of motion. Or this will be the simple idea is there, Balak. See, I want a minimum value of force. Okay, I want a minimum value of force such that the body should move. Now, what is happening that in any scenario, this body is getting stopped. Stopped by which force? F max. So at least over here, let's suppose I said that F max is 10 Newton. You know that if I apply at least 10 Newton, then the body will come into a state of motion or not. Imagine that if you apply 9 Newton, is the body will ever come into the state of motion? No. If I apply 11 Newton, of course the body will come into motion. But 10 Newton is that value where the body has tendency of motion or not. Say me something, yes or no?
तो पर वहां पे तो रेस्ट पे रहेगी ना वो।
हाँ हाँ क्या?
10 न्यूटन लगाने पे तो रेस्ट पे रहेगी वो।
हाँ अरे रेस्ट पे रहेगी, क्यों रेस्ट पे रहेगी? क्योंकि तूने उसको अभी मतलब अच्छा मान ले अगर मैंने 10.01 लगा दिया तो क्या मोशन में आएगा कि नहीं आएगा?
5%।
आ जाएगा। अगर मान ले मैंने 9.99 लगाया, क्या वो मोशन में रहेगा?
नहीं।
नहीं। तो 10 this 10 Newton is which value? 10 Newton is that value where the both states are residing or not, a state of rest and a state of motion, and this is why it is called as limiting friction also. Is that clear or not? So body has a tendency when F minimum means minimum value for which the body has a tendency of motion is how much Newton? At least 10 Newton. More than 10 Newton, definitely there is an acceleration, but 10 Newton is that value which I should definitely anyhow I should apply such that I should have an acceleration or not. Is that clear or not? So this is what I was saying, that anyhow your applied force means which force is accelerating is F cos theta. F cos theta must be equal to F max at least. Are you will get me or not? Clear? हाँ हाँ मतलब F cos theta जब हम लेंगे तो वो मिनिमम फोर्स है. इज दैट क्लियर और नॉट? तो F max की वैल्यू है क्या? म्यू इनटू एन. म्यू एन की वैल्यू क्या है? mg माइनस एफ साइन थीटा विच इज इक्वल टू हाउ मच? F cos थीटा. अब ध्यान से देख व्हाट इज द वैल्यू ऑफ F देन म्यू F. सो दिस विल कम एज म्यू mg. इसको इधर लेकर जाएगी तो ऐड हो जाएगा एंड इट विल कम एज mu mg by cos theta plus mu sin theta. This means that this frictional force is, sorry, this applied force is varying with angle theta or not? Are you able to get me? If I change the value of theta, the value of condition will change. So this means that if I want to find minimum and maximum, I have told you once, I have told you once that to find any value of minimum and maximum, learn this idea. To find minimum and maximum, you have to do differentiation. What you have to do always, guys? Differentiation. Without any differentiation, you cannot find minimum or maximum. Now, you have to see how to do this difference. हाँ बोलो.
Sir, why is we are doing 30 minus standard instead of 30 plus standard?
क्या क्या क्या?
Sir, तो mg है
हाँ.
और n mg plus standard नहीं होगा.
N is equal to mg plus f sin theta.
Yes sir.
अरे भाई ये ऊपर नीचे मूव कर रहा है क्या? नहीं ना. तो इक्वेशन क्या है? ऊपर फोर्स n प्लस f sin थीटा इज इक्वल टू mg ना. तो n की वैल्यू क्या आएगी? mg माइनस f sin थीटा.
अच्छा.
समझ में आया? अब ध्यान से देखो तो ये फोर्स मतलब ये जो अप्लाइड फोर्स है बेटा वो क्या चीज के ऊपर डिपेंड करता है? इस थीटा पे. जैसे जैसे थीटा चेंज होगा वैसे वैसे कंडीशन एफ की चेंज होगी. मींस दिस एफ विल इज डिपेंडेंट ऑन दिस थीटा. इफ आई चेंज द वैल्यू ऑफ थीटा एफ विल चेंज. So this means that I have to find also a value of theta where the friction force will be minimum or not. Say me something where the applied force should be minimum or not. How to find that? Basically, for that I need to differentiate it. How I am going to differentiate? I'll differentiate that variable which is dependent on the variable which is changing. So this force is dependent on theta, so I'll find df by what? D theta, and I'll put it equal to how much? 0. Mu mg is constant, so it will come outside. And look over here, I'll change the marker. This is mu mg, and differentiation of 1 by something is minus 1 by cos theta plus mu sin theta का whole square into internal term differentiation. Cos theta is basically minus sin theta plus mu sin theta is mu cos theta, and that is equal to how much? 0. So this whole term can be sent over there and can be made equal to 0. So sin theta is basically equal to mu cos theta, which means that I need theta is equal to tan inverse mu, where means I need with means this is the state of f minimum, that is correct. But I need a special theta also, that this theta must be exactly equal to tan inverse mu such that this f minimum is satisfied over there. Now what will be F minimum in that state? So properly I can find the value of F minimum now. That F minimum which can be applied based on mu and based on mass, which can be written as what? If theta is tan inverse mu, I can write even sine theta. Sine theta, see, tan theta is equal to mu, correct? Mu by 1. Perpendicular is 1, base is 1. So sine theta is perpendicular by hypotenuse 1 plus mu square, and cos theta will be 1 by root over 1 plus mu square. So this one will come as mu mg divided by 1 by root over 1 plus mu square plus mu square upon root over 1 plus mu square, which comes as mu mg mu mg divided by root over 1 plus mu square. Means if you apply this much minimum force at this much angle, then the body will start moving. The body will come into the tendency of moving. And maximum value can be anything. Are you able to get me or not? Is this clear or not clear? अगेन मैं रिपीट करता हूं, पहले मैंने क्या किया, I resolved the force. I found out that how much I can apply my force such that the body can move. But this force, I saw that it was variable on theta. Now I can select a special theta for this, for which I can apply minimum value. I found out that if tan theta is exactly equal to mu, I can apply a force which can be minimum such that the body can easily move. So I selected a theta which is equal to tan inverse mu, and then for that at this stage the F minimum applied must be equal to how much? Mu mg by root over 1 plus mu square. Then the body will have always a tendency to move in a forward direction. Is that clear or not clear? Did you get my point or not? बच्चे डाइजेस्ट हुआ ये सब? सुरुचि, इफ मैक्स, अच्छा एक बात बता, तूने मिनिमम पता कर लिया, अभी मैंने तेरे को बताया कि ये बॉडी है जिसके लिए एफ मैक्स की वैल्यू है 10 न्यूटन। तो अगर मैंने 10 न्यूटन अप्लाई किया तो ये मूव करने लगा, लेकिन मैं ऐसे अगर इस डायरेक्शन में 10 न्यूटन अप्लाई किया किसी थीटा पे, तो हमें पता नहीं ना कि एक्सेलरेट करेगा कि नहीं करेगा। तो हमने उसका कंडीशन निकाला कि हाँ बेटा ये थीटा क्या होना चाहिए, tan इनवर्स म्यू, और इसकी वैल्यू क्या होनी चाहिए, म्यू mg by root over 1 plus म्यू इसका। बट आई नो दैट any value which is more than 10 newton, like if I take 20 newton, this body will move or not, 30 newton, this body will, 40 newton, this body will. So any infinity, I can take any value till infinity and the body is going to always move. But what is the minimum value which I should apply such that the body is moving is this much only. Is that clear or not? And that's why I said that maximum value of that force can be anything. Are you able to get me or not? Is that clear? I think this question took us into a lot of depth. Is that clear or not clear? So first we did PhD, then we understood a simple question, and then I brought you an idea of minimum value of force which can be applied to move a body on a rough surface, which can be at angle theta. Is that clear?
Yes.
Okay. Now, next type of problem, insect on a hemispherical ball. बेटा ये सब क्वेश्चन तो मैं पकड़ लेता हूँ, और सारे ये सब जो क्वेश्चन है ना, और सारे टीचरों को पकड़ने में ना उनकी मतलब ऐसे मम्मी पापा पैंट्स लेकर लाएंगे खरीद खरीद कर। तो मैंने पता है ऐसे एक टीचर को इस बार सुना दिया, भाई मैं जिस तरह का क्वेश्चन पकड़ता रहा तुम्हारे पकड़ने में ना मम्मी पापा पैंट्स लेकर आना पड़ेगा। टीचर भड़क गया मेरे ऊपर, बोला मैं लगाऊंगा तुम्हारे ऊपर एक्ट, लगाऊंगा तुम्हारे ऊपर कंप्लेन। मैंने बोला लगा डाल। समझ रहे हो बालक? दिस काइंड ऑफ डिटर्मिनेशन यू नीड इन योर लाइफ। अच्छा मैंने इधर कुछ पिक्चर्स डाले थे, हेमिस्फेयर वगैरह के हैं क्या? नहीं भाई इसमें सारे स्फेयर ही हैं।
तो मेरे इधर कोचिंग वाले सर ने तो पकड़े हुए हैं, तो फिर कुछ पकड़े हुए हैं, तो कुछ समझ नहीं आता।
क्या क्या क्या?
इधर तो सारे नोट कपड़े क्वेश्चन कपड़े हो।
अच्छा।
आपको मैं नोट्स भेजूंगी।
हाँ हाँ हाँ।
मतलब कुछ टीचर्स पकड़ लेते हैं, मतलब ऐसा बोलना तो मत।
अच्छा अच्छा, तो मतलब उनको बोल एक बार डैडी जी से बात करने के लिए। डैडी,
डायरेक्टर वो आते हैं।
डैडी जी इधर बैठे हुए हैं, है ना? है कि नहीं? मान ले हेमिस्फेरिकल बाउल है, ठीक है भाई, हेमिस्फेयर तो ड्रॉ नहीं हो पा रहा है यार। आई वांट, हाँ हाँ, इसको ऐसे उल्टा घुमा देते हैं। अबे घूम जा, अबे ए, सिट। नहीं हो सकता ये ये आज नहीं मानेगा। इसको घूमने का नहीं है। अरे छोड़ दे भाई, डिलीट। अरे छोड़ दे, मैं नॉर्मल सर्कल ही उठा लेता हूँ, सर्कल को हेमिस्फीयर बना डालूंगा मैं, देख तू कैसे। ठीक, मान ले एक हेमिस्फेरिकल बॉल है इसमें, इसी के अंदर, ठीक है, देयर इज एन हेमिस्फेरिकल बॉल और and I'm considering the reason till over here. What it or not means this reason, this particular reason. In this reason, what I did, this is a rough surface. What it or not, whose coefficient of friction is mu, and let's suppose my here in your group nowadays, my own brother is also studying. Okay, so let's suppose he dies and after not cracking NEET and took a birth as an ant, got it or not, whose mass is him. I kill him, got it or not. Question is same thing. Find the maximum height till which the insect can crawl up to. Find the maximum height till which the insect can crawl up to. Tell me the answer. अरे हमें कौन रोकेगा, हम तो खुद छोड़ के निकले थे। Tell me the answer guys, fast. See,
सर इसका आंसर कुछ ऐसे नहीं करते
बता। हाँ 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 डालने से हो जाएगा। हाँ सही है सही है, ऐसे ही होगा, ऐसे ही होगा, ऐसे ही होगा। अच्छा, look over here guys, this insect is crawling, okay. Imagine that till here it crawls, this is its maximum height, okay. It comes over here and this is its maximum height till over here. Got the idea or not? And let's suppose its mass is m, okay. At that time it makes an angle theta over here. Its weight is mg, okay. This is mg, and if you look over here at this time, means along this direction itself, along the direction of radius, I can consider this angle to be theta. So this will be again mg cos theta, and this will be mg sin theta. Correct or not? Now you know that along the tangential, if anything is perpendicular, normal is always perpendicular to tangential surfaces. So this is my normal direction. At maximum height, this is, look over here, I am selecting this diagram. This over here, let's suppose from the ground is my h max. You tell me, when this ant or whatever it is there, this insect is there, it reaches maximum height, you know that furthermore it cannot, means this cannot rise furthermore upwards. What will happen then? The body, this mass, this particular insect has now much more tendency to fall downwards or not. Same is something, yes or no? So this means that at maximum height, particularly in upward direction, as the body has a tendency to fall down, the body will experience a frictional force in which direction? Upward direction. This is my F required. Now, when it is at maximum height, body is fully in tendency to fall down. So what will happen? The surface will apply maximum force such that which can balance mg sin theta, such that the insect should not fall down. Are you able to get me or not? It should not be equal to mg sin theta. Means, see, this F required is not equal to mg sin theta. F required is basically over here F max. Why F max? Because I am present at maximum height, where I have the highest tendency that I will crawl down. Are you able to get me or not? Is this clear or not clear? Now F max is what? Mu into n mg sin theta. Mu, भाई गर्दन दुखने लगा, इतना जोर जोर से मैं बोल रहा हूँ आज। एक तो इतने सारे क्लास, फिर भी पढ़ा रहा हूँ तुम लोगों के लिए. So tan theta is equal to how much? Mu. Now look over here. This distance is again how much? This is, you know that r. This is radius r. So this will be again r cos theta. So what is my h max value? Simple it is. H max is r minus r cos theta. Now r common, 1 minus cos theta is how much? Look over here. Cos theta, tan theta is mu by 1. So cos theta is base, which is 1 by hypotenuse, which is 1 by mu square. This is your answer. This is my H max till which the body will rise up. Are you able to get me or not? Clear हुआ कि नहीं हुआ यार? बताओ. Clear? सही समझ में आया? ओके. नाउ क्या क्या यार, आवाज नहीं आ रही है अच्छे से, जोर से बोल. नहीं, हेमिस्फेयर के देख, अगर इसके पास टेंडेंसी रहा, अगर इसके पास मतलब हम क्वेश्चन क्या लिखे हैं, क्वेश्चन में ही तो बोल दिया. इन द क्वेश्चन आल्सो इट इज विजिबल दैट आई वांट टू रीच टू अ मैक्सिमम हाइट, ओके. Of course, its maximum value of height it can reach is capital R, but whether it is reaching over there or not, I have to understand that. What happens over here, you know that somewhere this pulling force mg sin theta will dominate definitely. मतलब हाँ मतलब तू ही सोच, तू भाई स्पाइडरमैन थोड़ी ना है, मतलब मोस्टली अगर तू ये सोच कि ऊपर जो है, ऊपर में क्या हो जा रहा है, फुली वर्टिकल हो जा रहा है, यहाँ पे फ्रिक्शन कहाँ लगेगा, ऊपर की ओर लगेगा, और उस फ्रिक्शन की वैल्यू क्या होनी चाहिए, mg, लेकिन वहां तो मिल ही नहीं पाएगा ना mg, समझ में आया कि नहीं आया? तो इसकी वजह से वो ऊपर तक पहुंच ही नहीं पाएगा, मींस इट कैन नॉट राइज टू दैट मैक्सिमम हाइट, ये बीच में ही इसकी ताकत खत्म हो जाएगी। समझ में आ गया कि नहीं आया? तो अब अपने को अगर ऊपर की ओर जाना है तो अपने को क्या सोचना पड़ेगा, अगर मान ले मेरे को किसी ब्लॉक को इस तरह से, मतलब क्या हो रहा है कि यहाँ पे देख, ये जो रीजन है ना, यहाँ पे ऑलमोस्ट ऐसा स्ट्रेट लाइन बन रहा है, कर्वेचर परफेक्ट स्ट्रेट हो जा रही है, लेकिन ये जे एडवांस में एक क्वेश्चन आया हुआ है, हरिओम तुम ट्राई कर सकते हो कि अगर मान ले कर्वेचर स्ट्रेट हुआ तो कैसे, कौन सी फ्रिक्शन लगेगी और कितनी लगनी चाहिए। समझ में आया कि नहीं आया? मैं भेज दूँ, मैं भेज दूंगा, ये क्वेश्चन बहुत अच्छा क्वेश्चन दिया हुआ है, वो डबल डिफरेंशिएशन से बनता है, ठीक है।
सर एक एफबीडी का बड़ा बढ़िया एग्जांपल था।
एक एक क्या,
एफबीडी का बढ़िया एग्जांपल।
एक एफबीडी का बढ़िया एग्जांपल चाहिए? बेटा तुम एक काम करो, लो तुम एक क्वेश्चन जाके बना डालना, मान लो इस तरह से, अच्छा रुक एक मिनट, ड्रॉ करने दे, ये मेरा फेवरेट क्वेश्चन है, दिस इज माय फेवरेट क्वेश्चन व्हिच आई एम गिविंग यू अ परफेक्ट क्लासिक एग्जांपल ऑफ एफबीडी। ओके, two masses are placed like this way and the surfaces are like this way. Okay, draw their FBD and find each and every contact force. This is M1, this is M2, ठीक है, सोच के बताना क्या होगा, समझ में आया कि नहीं आया? ठीक है, हाँ, और भेज दूंगा एफबीडी का, एफबीडी का बहुत सारा है मेरे पास, ठीक है। तो look over here, we'll keep till over here today, and tomorrow we are again going to meet. We are left out with chain problem, two body problem, two body on an incline problem, and then we'll finish this topic. Is that clear or not? Are you able to get me? Means one more lecture or two more lectures, then this topic will be fully finished. Is that clear?
Yes.
Are you able to get me?